This is the Arduino Nano, and here we have the MOSFET. The MOSFET has power pins and the gate. So these two are power, and this one is the gate wire. The gate wire goes to digital pin 5, digital pin number 5. And for now we just hook up these two. So that is the MOSFET. We also hook up power to the Arduino, and we use the V-in voltage in and not the 5 volts. The V-in is the unregulated power source, so batteries use V-in because batteries don't always give 5 volts, especially when you use LiPos. LiPos is at 7 or 11 volts, so you always use V-in. The ground pins goes to GND ground. So that's input power to the Arduino. We want to use the analog pin 0, but to do this we need 5 volts or less. So we use a voltage divider which has a 100 kilo ohms and a 10 kilo ohms resistor. Use this voltage divider to lower the voltage from the battery down to 5 volts or less. So to simulate a trigger we use this one, push button, to simulate the trigger. Let's put this down here. So this is the trigger. The trigger, of course, one side is tied directly to the power, and the other side will be tied to the input of the voltage divider. So when we press the trigger, there's a connection through the trigger into the 100 kilo ohms resistor, dividing it into 2 sections, ground and a lower voltage output. The lower voltage output can then be used directly as input. So this wire will always be below 5 volts as long as you don't hook up more than 30 volts. Then it will be less than. Actually, we can go all the way up to 50 volts, but I recommend to stay below 30 volts to accommodate for voltage spikes when connecting and disconnecting batteries and stuff like that. And the input goes to analog 0, A0, on the Arduino board. So when you push the trigger, the A0 input pin sees a voltage, so you know the trigger has been pulled. And that's kind of it. So ground, power goes also to the trigger, and the trigger pin goes to the input of the voltage divider. The output of the voltage divider goes to A0, and the last piece missing is to connect the ground of the voltage divider to ground, and then it's ready to hook up. Now we are ready to plug it into the USB port. Plug it in. And when you plug it in, the lights come on. So let's start coding. The first piece of code here is the config. The MOSFET gate will be connected to digital pin 5, and the trigger will be connected to analog 0 via the voltage divider. The voltage divider uses two resistors, one at 100 kilo ohms and one at 10 kilo ohms. If you change any of this up, change these values. Also, this value sets the minimum voltage that needs to be on the battery for the gun to turn on. Mine is 3.6 volts because it's a LiPo and 2 cells. This value is also something you need to configure. It's the maximum time the gun can be on, so it corresponds to a full burst cycle. So this is currently set to 200 milliseconds. So for my gearbox, it takes 200 milliseconds to do 3 shots. So this will make the gun a burst mode doing 3 shots. But you have to change this value to match your gearbox, and it depends on the gearbox rate of fire. So if the gearbox is a fast one, you need to set it lower, and if it's a very, very slow gun, then you need to set it higher. This is around a standard, what a standard gun uses. When you hit the upload button, the code compiles, and when it's done compiling, it should upload it to the Arduino board. And when it's uploading, it starts blinking fast. And then it's done uploading. So to test this, the MOSFET goes to the battery, and the other side, right now I'm using a converter, but goes directly to the gearbox. So what I will do is gonna hold this one in, and I'm gonna push the button, and when it's on burst mode, it should fire. So let's give it some power. Turn on. LED turns on, and all that I did was hook up the battery, and then the LED turns on. Right now, this one should be the contact on this one. So right now, when I pull the trigger, nothing happens, because this one is our simulated trigger, not this one. Otherwise these two wires should be hooked up down here. So 3 shots. And there you have it, burst mode controlled with an Arduino. first cut out the headers, 2 singles and 1 double for the power. Solder on the headers and try to make them look just a little bit nice. Now cut out a piece of copper board in the same size of the Arduino. Then I mark out where the Arduino pins are so that I can isolate them one by one. What I do is I take an X-Acto knife and just cuts off the copper that I don't want to be there, where I don't want connections to be. On the MOSFET itself, I bent down the connection pins so that it will lie flat on the copper. And when I solder on the connectors, I first solder on one of the legs to hold it in place, and then afterwards I solder the rest. And on the top part I touch it gently after soldering to make sure it doesn't overheat. Then I solder on the resistor that goes between the gate and the drain pins, the 2 pins in the bottom. Then I solder on the gate resistor, which is what the Arduino is going to hook up to pin number digital 5 to control the MOSFET, turn it on and off. Then I solder on the 2 resistors, which makes up the voltage divider. I then hook up an extension wire to where I want the input pin from the trigger to be, because I want it on the top side of the MOSFET. Now this is what it looks like right now. So now I hook up the Arduino and solder on all the headers from the Arduino to the PCB board. I then add some small pieces of wire so that I can attach some T-plugs so that it can be connected easily to the gun. The 2 pieces of black wire is for the ground, and I use a red wire that goes directly from one T-plug directly to the other one with power. And on the power pin I add a small orange wire just to take power directly from the battery and connect it to the voltage input on the Arduino board so that the Arduino gets power. Now to test it, I first need to rewire the gearbox, and this is to accommodate for the MOSFET. And you do this by desoldering one wire, the wire coming from the battery usually, and attach it directly to the motor. The easiest way to do this is to do it directly on the trigger. So you just move one wire on the trigger from the one connection and then over to the motor, so that the motor will be connected directly to the input plug. I then attach the MOSFET input wire to the other side of the trigger contact. So now when it's hooked up, there's power on the left side, and when the trigger is pulled, the power also goes to the input pin on the MOSFET. And the Arduino can then see that the trigger is pulled and turn on the MOSFET so that the motor can have a connection to ground also. And only when the motor is connected to both power and ground will it shoot. So that's how it works. Perfect. So now you know how to make a burst mode MOSFET, and it's actually what most of the AEG guns does when they have burst mode. Click here to subscribe, or click below to see how to make just a basic MOSFET.